Yeah, uh, good evening, one and all, and we are welcoming that this particular webinar for VLSI semiconductor chip industry overview and prospects of that. So I would like to introduce that my colleagues and my panel members, uh, Professor J.V. Savanthran Madam Garu, HOD, Department of EEC Department, and another colleague of mine, Murali Krishna Garu. Uh, these two are trying to be address this particular event. So first, let me introduce the speakers, a brief point of view. Professor J.V. Savanthlan Madam Garu has obtained her doctoral degree from Andhra University. She is a passionate teacher with 20 years of rich experience in teaching ECE subjects. Her research area of interest are digital signal processing, image processing, and radar signal processing. She successfully guided 4 students in obtaining the doctoral degree, and currently 12 scholars are working under her guidance. Not only teaching, she rendered her services as assistant principal in Geetham Institute of Technology for 8 years. And Madam achievements are 4 scholars are completed their PhD, and around 60 publications in reputed journals and conferences. My requested Savanthlan Madam Garu, please address the gathering to say a few words about enlightening this particular workshop.
Okay.
Thank you.
Thank you, Naresh. Good evening and a very hearty welcome to the participants of this seminar. As introduced, I am Samithlin, a HOD of EEC department, and I'm really delighted to be with you all this evening. So I just want to say a few words about our department. In our department, there are 104 faculty, out of which 8 are professors, 13 are associate professors, and 84 are assistant professors. And almost 50% of our faculty are doctorates, and the remaining faculty are pursuing their PhD. Regarding the experience of the faculty, almost 50% of our faculty are more than 50, actually more than 50% of faculty do have experience more than 15 years. And about the programs offered, the MTech programs offered by department, we do offer MTech VLSI design, MTech electronic design and technology in collaboration with CDAC Hyderabad, and MTech power system and automation. And about MTech VLSI design, we do have almost a dozen faculty who are really experts in the field of VLSI, and our VLSI lab is equipped with state-of-art hardware and software. And almost all our alumni are well placed, and we really have good placement records. This webinar is actually to apprise you about VLSI, its scope of the VLSI and its scope, and also about VLSI in Geetham. And I'm really happy to hand over this session to my faculty, Murali Krishna, who's a giant and expert in the field of VLSI. So over to you, Murali Krishna.
Thank you, madam. Thank you.
Thank you, madam. And before sir is giving a lecture, let me introduce that my colleague Murali Krishna Garu. Murali Krishna Garu worked as RF and embedded digital design in a private defense lab, and he has industrial experience and well versed with VLSI EDA tools such as Cadence, Synopsys, and Siemens EDA tools, and such as Virtuos, and so many of things, and he's having a good experience in this particular simulation part of that. And he guided over 120 PG students in various fields of digital and analog and ASCII VLSI designs and all. And not only this, and Sar is mentor and guided to help the students to pursue their dream career in the field of electronics. And we are very much thankful to accepting this invitation to give this particular webinar. And thank you, sir. Thank you very much. And thank you, HOD Madam Garu, to accept our invitation to interact with the webinars. Thank you, sir. And over to you, sir, Murali Krishna.
Thank you, Naresh. Yeah, good evening, everybody. I hope I'm audible to all. Yes, Naresh, I'm audible.
Yes, sir. Yes, sir.
Yes,
Audible.
Yeah, thank you.
Yes, Madhukrishna, you're audible.
Yeah. Welcome to the webinar on VLSI, the semiconductor chip industry and overview and prospects. I'll just first start with the semiconductor overview and then take on why VLSI and then VLSI in India and followed by VLSI in Japan. Okay, so that will be my agenda for today. Welcome all to Geetham. Welcome to this new learning experience. From the last 1 year, we have been experiencing a new learning experience due to COVID, and most of our classes and the labs are online, and we have been doing 24-hour hands-on training for the students also. So that's the new experience we are doing now. So let us start with the semiconductor industry, how it evolved and everything. So first, it started with the vacuum tubes. I think you not have seen the transistor-based vacuum tubes, radios, or other things. And then the first transistor was evolved in Bell Labs. Then the first IC was evolved in Texas Instruments, TI Lab. And from there, the modern microprocessor evolved. So today you see a lot of integrated, like billions of transistors in a IC. So that's the evolution of the transistor. And most of this could happen because of the device called MOSFET. Previously, people started working on NMOS, and then combining NMOS and PMOS, CMOS, that gave a very good device which gave power and other switching activities that lead to this particular inventions of 8-bit microprocessor in 1970, where the Intel brought this particular processor using the NMOS device. Then it evolved using the Moore's law that transistor density on an integrated circuit doubles every 2 years. So that is still happening today. Okay. So today we see a 64-bit microprocessor with 8 core, 16 core, and 32 core also. So there are billions of transistors that are evolved in this particular era. So Moore's law still holds good. And what is the fabrication technology node trend that has been happening? Late like 1970, when the Intel brought their first microprocessor 4004, it was in the 10 micrometer technology node. Now from there, it evolved with 5 micrometer, then 3 micrometer, then 1.5, and so on. That was the micro technology node. Then we started with a nanotechnology node, basically called the VLSI thing. It was like, say, 250 nanometer node from there onwards. Then it came into the basic era of like 180 nanometer, 90 nanometer, and so on. Today, we are in the era of 7 nanometer and 5 nanometer era. At the end of the thing, I'll be able to show you that the IBM has produced a 2 nanometer chip with fabrication, everything they have done. So, and Intel is trying, Samsung is trying to do a 1.5 nanometer chip now. So there are revolutionary CMOS which are applicable now, and they have changed the way that we actually studied our CMOS. So that I'll be able to show you at the end of the session. So this is the evolvement. So we started with 10 micrometer, and today we are at the 7 nanometer fabrication now. Okay, this is already in the production. So a lot of the micro mobile chips, whatever you find, are the FinFET technology which are using the 14 nanometer and the 7 nanometer nodes. So why VLSI? So these are semiconductors are everywhere actually. So you can find semiconductor in your toothbrush. You can find a semiconductor in your car, in your home, which is a smart home. Everywhere you can find out the semiconductor. And almost if you see that, the total time in 24 hours, you spend at least 20 to like 18 hours of your day with semiconductors only. You watch TV, you use mobile phone, you use your smart gadgets. All these things are basically the semiconductors. So with this semiconductor, these are the basic foundation for your modern technology. Without this, I think it would not been possible, because we are trying to embed more and more transistors into these particular chips. This particular, like the chip and the semiconductors are used in various fields of technology, like including transportation, healthcare, robotics, IoT, smart energies, and computing. Basic computing, you already know. Now, if you take a car or a transportation device, all these also use a chip. Okay. The basic IoT, which is evolving now, the IoT is a market for today, and it requires a lot of chips for that. For the sensors, utility, everything, they require a lot of chips. So these are the various fields of engineering it requires. Like in the communication, you can see the radio, scanner, smartphones, television, everywhere it requires a chip. In computing, like laptop, diode, CPU, everywhere it requires chips. Consumer and IoT also we require like the ATMs, video games, coffee makers, all these require the chips. And the healthcare, this is a basic now due to COVID, the production on this particular healthcare has increased a lot. Then the smart energy, like if I have a smart home, which saves a lot of energy from using that particular technology. And in the transportation, we have navigating on the wireless, driverless cars. Okay, and most of the today's car are having a lot of chips inside it. And they're using that most of the protocols for communication. So this was like 12 plus hours on a day. Each of the adult spends on time on these particular electronic gadgets. This is a source from Intel, which has published a white paper on this. And most of the factory fitted electronics are in the car. You take the braking system, you take your engine, you take your consumptions of petrol or diesel. All these are electronically done now. So a lot of electronics are embedded into your car. So we can finally say that there are chips everywhere, and the demand for these chips are increasing day by day. So why VLSI? Yes, VLSI is a need for the hour, and we require good VLSI engineers to do these particular chip designs. If you see this particular graph, it shows that the percentage of company having difficulty in filling the companies, the openings for this. So if you take this electrical energy engineering gap, is about 60%, whereas the other things are only 30%. So you just need to fill this gap. If you're just knowledgeable of the basic foundations of electrical energy or electrical electronics thing, you'll be able to easily absorb it. So this gap we'll be trying to filling up. So this is what the industry is requiring, and we are not able to give those particular good engineers to the industry. So we just need to fill this gap, and Geetam is ahead on this particular task also. The market of VLSI industry is going very fast. From 2020, it was like 54 billion, and in 2022, it is almost touching 110 billion. So it's almost 50% increase in that. And this brings a great opportunity for fresh graduates to pursue their VLSI as career. Why? Because there are a lot of startups coming on, and there is a made in India concept from Narendra Modi sir. So these initiatives have brought up new companies to start their design units, and help the other big semiconductor companies to wind up their designs as fast as possible. Okay. So let us now understand what is a VLSI design flow. So first thing is, there are different aspects of design in VLSI that we need to understand first. And depending on that, one students can choose one of the areas where he can pursue his career. These are the different design abstractions level that we follow. So a student can actually first understand what is a system. Then from there, we break down into different modules of that. And from that, we go to the gate level of instances of each of the module. And then we convert into circuit level, and then to into device level. So this is the hierarchy or abstraction level a student has to understand. And student can start at different level of abstraction also. So a student could be interested to only pursue a schematic design of a design. So you can do that. Some students only prefer to do the layout. So there are different jobs at each of these particular hierarchy levels. Okay, but as a student, we should be able to understand different areas of this abstraction and able to design at different areas of this abstraction also. So let us see one examples of this. In the block level, we actually see what is a transmitter or a specification of the transmitter we will be giving. And at the RTL level, we'll be writing the Verilog code for this. And at the gate level, we'll be trying to do the schematic design for this. And then at the circuit at transistor level, we'll be trying to do the MOSFET design for these particular schematics. Then at the device or mask level, we'll be doing the layout for this design. And at the chip level, we'll be fabricating these chips. And at the system level, we'll be integrating in some of the motherboards. So this is a hierarchy that is maintained. And it is not that a student will pursue a career in all these levels, nothing. He has to take one particular level of the hierarchy and pursue his career. But at the study level, you should be able to understand what are these different levels and what are the different designs for each of the levels. So once you understand that, you'll be able to pursue or take a chance in pursuing one of the careers at different levels. And this is a typical Y chart design domains that VLSI design has. First is the behavioral domain and the structural domain and the physical domain. So a student can start designing from a behavioral domain and can go to the physical domain, or can start with the structural domain and physical domain. Okay, so this is just for understanding of the Y chart. Okay, so you can just pursue with a behavior, because once you know what is the specification of that and what is the design, then if you can break down, then it is easy to do at structural level. But if you're not able to understand that, then you can start with the behavioral level and then go to the physical domain. What are the different VLSI design methodologies? So this is what we'll be able to teach in given. So first is a full custom design flow, where a student can pursue an analog design or a digital design in full custom. Then semi-custom or ASIC design flow. So if specific IC requires some particular design criteria, so in that case, we can go for a semi-custom or ASIC design flow. This is only for a digital mode. Then we can go for an FPGA design flow, where the time to market is very less. Then in that case, we go for a FPGA design flow. Now this FPGA design flow is also called as front-end design flow, and this full custom design flow is also called as back-end design flow. Let us just give a glance at what is a different design flow. We'll not just go in detail of it, just put a glance on it. So FPGA is one design flow, and ASIC. Within this ASIC, we have full custom and semi-custom. So let us pursue the FPGA design flow. So if you here see what is the entry level is an HDL. So you should be able to write a Verilog code or an HDL code, and then try to simulate, synthesize, and create a bit file and load it into one of the FPGAs. So this FPGA design flow is also called as front-end design flow. Okay. So some of the engineers also pursue their higher understanding here. They are called as RTL designers. The second one is full custom design flow, where people start doing their schematic design in CMOS, then simulation, then do the layout, and then do a GDS format. So then create a GDS format, and this GDS format file is given to the fabricator to tape out the IC. Now these engineers are called as back-end designers, or basically when they do the layout, they called as layout designers. Okay. And the third one is your semi-custom design flow. So depending on the libraries available, depending on the different cells which are available, we can pursue our ASIC design flow. This is also called as a physical design flow, that is thing. So first thing is you can pursue an RTL engineer or a layout engineer or a physical design engineer. So these are three major criteria design flows design engineers can pursue their opportunities. Typical front-end design and development flow. So given a particular design requirement, you should be able to do an RTL, then synthesize it and program this device. So whenever you have a criteria to market a particular design at a very fast rate, in that case, we go for the front-end design flow. But when you have a lot of time and we have a specification for low power or a low area or something like that, in that case, we go for a back-end design flow or a full custom design flow. So once the designs are done, once the designs are created and the GDS2 formats are done, this is given to the fabrication companies. They create a lot of mask of that. So all these things will be dealt, like masking is to create the IC format of that, and then do the fabrication of it. And then these fabrication are embedded into the die and then sorted. And then after that, they are done the testing and assembly. And then they are sent to the warehousing where they are manufactured and cutted. So then you get this particular IC. So there's a lot of things which is involved. And India is basically a fabless country where we don't have any fab at this point of today. But we are expecting within 2 years that STM and Samsung are going to start their fab in Noida. So that is the expectation. And they've also given India, the government of India has also cleared the fabrication for these two companies also. So as a engineer, what you are interested in purely on the design aspect. Okay. And these are the three important design metrics that we actually follow in our constraints. So first is your power, then speed and area. And everyone knows that we require low power because we want to run our battery for a long time, and low area because we should be able to embed a lot of programs or a lot of functionality into that particular thing, and high speed. And if I'm doing a gaming thing, I should be able to do those things at a very high rate. So those are the basic criteria, and most of the design companies are working on these design targets only. And let us see why VLSI in India. So there's a huge boom. It is expected that by 2020, the semiconductor design market in India is expected to increase by 30%. And there's a lot of opportunity for the Indian students to pursue their career in semiconductor. Okay, with this COVID, a lot of companies are switching from China to India, and a lot of boom has been created in India also. And there are a lot of new startups which have started in Bangalore, Pune, and Noida also. So you need to just catch this market and pursue your career in VLSI. And significant reason for semiconductor growth is because there is the domestic consumption, which is more is increasing because everybody requires a smartphone, every car requires a smartphone, every home requires a smart product. So all these require chips. So that's the huge market which is being developed. And the other important thing is the competitive landscape of semiconductor in India. Why? Because we have the best 10 fabless countries, design companies in India. We have the 19 of the top 25 semiconductor companies in India, like Intel, Texas Instruments, and everything. 125 plus IC design companies in India, like NVIDIA, Broadcom, Qualcomm. We have the top 500 plus embedded companies in India. Okay. And then we have a strong related verticals, like we go for automotives, like electronics and telecommunication and IT hardware and all these things. And the most important thing is we have a good engineering workforce, but we need to improve their talent and knowledge. That's the most important thing. That is where we lag. And that is, we have good engineers, but we lag somewhere in the knowledge side. So that Geetam is trying to put a lot of efforts on that. And the other thing is the low operational cost that India is giving. So these are the basic things why you should pursue your career in VLSI. Opportunities in VLSI. There are a lot of companies like product companies in India and service-based companies. These service-based companies help these particular semiconductor companies in terms of completing their projects. It's not that if I take an Intel, Intel doesn't absorb a lot of manpower for pursuing a particular design to complete that. So what they do is they break up their design tasks to different companies, basically the service-based companies, and they complete their designs. And most of the Indian companies, what you find in Bangalore, Pune, and Noida, are service-based companies, and these help the students to pursue their career. Okay, like these, if you take Wipro has bought about 10 to 12 companies on VLSI and started off a good service-based company, and they're giving a lot of services to their Intel, TI, and other big companies. These are the EDA companies, Cadence, Synopsys, Silvaco, Mentor Graphics, Ansys, and Keysight, where one can pursue an application support engineer, and the job site is also very good, competitive also. VLSI foundries which are not in India, hope they come to India now soon as possible. There's only one company in India that is called Semiconductor Complex, which is in the Department of Defense, part of the ISRO. They have only 180 nanometer node. They only fabricate 180 nanometer technology nodes only. And we have an MOU with SCL to manufacture or fabricate our IC. All these most companies are in US, Taiwan, some are in Japan. And these product-based companies that create chips or IPs can be classified in different domains. Like if you take processor, Intel, AMD, ARM, NVIDIA are different companies. Wireless communication kits for Qualcomm, Broadcom, mainly used for your mobile. Automotive, NXP, Infineon, analog devices. Memory, SanDisk, Rambus, and Micron. Mobile SoC, Apple and Samsung. So these are the most prominent players of these particular domains. And what is the expectation of the industry? First and fundamental thing is you should be able to be good in your engineering concepts. That is the fundamental thing. Some programming skills in basically C, then Verilog, and some Perl, some scripting language like Perl, TCL, or say Python. And good communication skill, you should be able to speak out your speak fluently, and good writing skills to communicate with your clients. So email writing is one important aspect of that. And aptitude skill. So that's primarily you join any CRT class, you have that aptitude skill. And the most important thing is a technology and domain skill. And that is where the students try to lag. And that is why we in GitHub try to help the students to pursue in this particular technology and domain skills. Okay. And that's very important area. And that's not, they basically ask the fundamental things, not the pure high level thing. They purely ask the technology related fundamental things. So basic knowledge and for VLSI jobs that is required is digital electronics, analog, CMOS device, and programming. So these are the basic fundamentals. See, if you understand digital electronics, then you should be able to write the code and understand it and write it very easily. When you talk about programming, we should be able to do C, then Verilog, some OOPS concept, because System Verilog, the new thing is System Verilog, which develops on a OOPS concept. Then some scripting languages like Perl, Tcl, or Python. Analog electronics to understand what is R, resistance, capacitance, and inductance, and op-amps. So basic design methodologies of small signal analysis or large signal analysis. And the fundamental thing is a CMOS device. So without CMOS, you will not be able to pursue your VLSI career. So if you're doing or we want to pursue a physical or ASIC design engineer job, you should be good in electronics, digital electronics, and CMOS devices. And if you want to pursue your as a layout engineer, then you should be good in analog electronics and CMOS devices. If you want to pursue your career as a DFT or testing engineer, then you should be good in digital, analog, and CMOS devices. And if you want to pursue as an RTL or verification engineer, then you should be good in digital electronics and programming. And basically, when I'm talking of programming here in the this design verification, we are dealing with Verilog and System Verilog. Okay, so these are the 4 prominent jobs that India is bagging on, and these are the different opportunities for VLSI engineers. So AMS and mixed signal designs, this is very prominent, but very tough. If you're good in analog, you can just try for this particular job area. And related to this is AMS is verification engineer. Then layout design engineer, already I explained that. Then board validation engineers are basically the PCB board validation engineers that do it. And these are the application engineer technical support that EDA companies try to get it. Okay. So VLSI at GitHub. So this is the important thing. So we offer MTech program in VLSI design and across 2 campuses, Visakhapatnam and Bangalore. And eligibility criteria is BE, BTech in and AMI in EC, EEE, E&I, instrumentation, CSC, IT, or its equivalent. And we also offer electronic design technology in Visakhapatnam and Hyderabad campus with eligibility criteria for BE, BTech, AMI in EC, EEE, E&I, or its equivalent. Okay. The session for EVP will be taken, I think the date will be announced. Today, I'm just focusing on the VLSI design part. The MTech in VLSI in Geetham is a AICTE approved program. It's a 2-year program with 1 year of project work. So we insist it's a 1-year program. 1 year, everything has to be done on a project. So you can start with a project in a company, or you can do an internship in that company, or you can pursue that the project in the campus itself. Electives are offered as per your interest area, maybe digital or analog. So depending on that, you can take one of these electives and pursue your interest. We have university partners with Cadence, Xilinx, ARM, RTM, Tanner EDA, which is now a part of Mentor Graphics, and now it is a part of Siemens, ANSYS, and Keysight. We have MOU with Semiconductor Complex Laboratory, Chandigarh, Texas Instruments, and Adaptives. And we are trying to do an MOU with Cerium System and MOS chip. Also, we are doing it. Maybe in a month or two, we'll be able to complete it. We have an holistic course experience in our thing. So each course offers lecture delivery. Nowadays, what we have done is, due to COVID, it is online. And we have taken the use of the LMS, the module which is integrated to the course. We have session quizzes for each of the session, which is delivered. Then we have module-wise assignments, and then module-wise quizzes and bits. Coursera is integrated into the course. Most of the assignments are also given from the Coursera. Credit transfer from SWAYAM courses are also integrated to this particular program. We do some industry standard case studies also. So for some of the topics, like if you're doing a Verilog, we do some designs related to UART or PCI Express. All these things has been done. Guest lecture from industry personnel is also dealt on monthly or half-yearly basis. Hands-on training for each of the particular things we will do in with the simulation assignment. So if you take a Cadence tool, we do a hands-on training for that, from the schematic to the layout and all these particular from the physical design flow also. We have a real-time implementation of designs on hardware board and EDA tools. So these hardware boards are given one-to-one for each student, and the systems are also given one-to-one for each of the systems. So what are the tools that we'll be using on all these things? I'll be just taking to the next slide. So we have integrated the module. Coursera is it, you have a 2-year license of Coursera given to each of the student once they join. So they can do a lot of courses from the Coursera also. We have hands-on laboratory experience based on the industry practice. So most of the courses which are there in the curriculum are integrated with the hands-on experience. So we have assignments related to that. We have each of the laboratory equipped with each of the courses. Flexible curriculum that support choice of courses with industry and research emphasis. Then highly experienced and skilled faculty. So most of the faculties have done their masters and specialization from IISc, IITs, and NITs. And some faculty have also pursued their PhDs in VLSI also. We have industry standard hardware boards and EDA tools. So in the following slide, I'll be able to show you the FPGA boards that we procured for your designs. And we have an excellent infrastructure. We have a dedicated PG and research students lab, exclusive for PG and research students. So it's a 24/7. Now we have a 24/7 VPN access to each of the students. Extensive alumni and placement support is given and during their internship and project work. So most of the students also support for their juniors internship and project work also. And the Coursera 2-year exclusive full access is given to all the courses in the Coursera. So these are the EDA tools and the hardware kits that we have in Geetham. We have a Cadence full PG research suite. Then we have Synopsys and Siemens suite also. We have Xilinx kits with the basic RTX 7 kit to Z-board and Net FPGA. We have the best RTM board, and we have the ARM university boards that we use for designing different embedded kits, different embedded designs also. So let us just understand. So if you take the Cadence, we have a complete suite. We have the schematic editors, then we have layout editors, and we have a physical design. So from the top end Verilog coding to verification, to schematic design, to their simulation, to layout design, to their simulation, post layout simulation, and then physical design also we have. So there's a complete suite of this, and we have a lot of PDKs that supports this design from taking from 180 nanometer node to 90, 45, and nowadays we also integrated the FinFET nodes also into our Cadence suite. And in the Xilinx, we use the Vizado software. We have the basic Nexus 4 kit that is powered by the RTX 7. And then we have the Z board, which is a very powerful board. And we have a net FPGA board that can be used for networking of different equipments. So these are the very powerful boards. This board is given for each of the students to pursue their labs and pursue their project work also. And some for students who are interested to pursue their projects on Z board also, they can do it. Siemens, we have a full custom suite, Tanner EDA, which is now acquired by Siemens. So we have the schematic flow, then netlist, then there is called as SEDIT, T-Spice, then LEDIT and WEDIT. So we have the waveform editor and everything. So students pursue their like digital IC design or analog IC design courses. Apart from that, they do that assignments and everything on these Cadence or Tanner EDA tools. So let us go for the testimonials of the students. So any question and answer we'll take after this testimonial. So let me just play this video.
Hello everyone, my name is Chetan and I did my integrated. Hello everyone, my name is Chetan and I did my integrated dual degree program with BTech in ECE and MTech in VLSI design from Geetham and got passed out in the year 2015 and of course with some flying colors. So right now I'm working as a team lead and senior engineer in analog circuit design with my specialization in core analog circuits like band gap, PLLs, bias, regulators, LDOs, etc. etc. So coming to me, nowadays it's everyone's dream to work in their own respective field of education. And in that aspect, I'm fortunate to achieve my passion and working in VLSI domain. And all this is because of my hard work and also the same continuous support which I received from Geetham. So I sincerely thank each and every professor of this esteemed university who helped me to achieve this particular goal. So without them, I'm nothing actually today. So guys, keep working hard and trust your professors. And thank you so much everyone for giving me this opportunity and all the very best.
He is Mr. Raghav Chetan. He was actually, Moschip has brought this company called Gigacom Semiconductor, which was there in Visakhapatnam. Now they have shifted to Hyderabad. There are about 10 students who actually were absorbed by this Gigacom Semiconductor. They are working on analog design. They are mostly working on band gap preferences, analog designs on each of the domains. The second student is the first batch student who is now working in Intel as a senior physical design engineer. So just read out the testimonial. Naresh, we can take some questions now.
Yes, sir.
Yeah.
So if anybody having a question, just you can ask the question and we will give it out. And meanwhile, if you have our, you can also post the questions and we will give the answer also. No problem.
Some students have raised hands, I think.
You can post it in the chat box.
Meanwhile, sir, I'd like to say that some of the students are recently they written that GAT entrance exam point of view, and also we done that counseling process also. Some of them are having a doubt and all. I'm taking general part of that, how our process and all works.
Yeah, let me complete this. I'll just complete the testimonials. Yeah. So he's our first batch student who is now working in Intel. The third testimonial is from Srinivasu, who is now a lead engineer in NXP. He's a 2012 batch.
So these are the few testimonials like that we have.
Yes, madam.
Yeah, which we are able to collect from the students.
There is a huge demand for VLSI engineers now, and the prospects are very high. Now, if you compare with the software company or the software jobs that you're doing, the starting package would be low for some of the companies, but as you grow at a 5-year span or after 5 years, the salary package, what you compare with the software engineer, is about 2 to 3 times more. So don't be saying that in the beginning I'm getting like 2.4 or 3.6 lakh. That's not going to, because when you get more and more experience, the package will automatically increase. I will say one student, he was from like 2016 batch, I think. So once he completed, he got a job in AMD with a 3.6 lakh package. Within 6 months, he was selected for Samsung with a 15 lakhs package. Now he's in Korea working for Samsung R&D at a 35 lakhs package. So see the way he has, because he was more knowledgeable, that's what. And one thing is, you should pursue that, because as you grow the experience, you get a lot of problems and then you understand what is the solution for that problem. And VLSI is not a field that if you are done today and you understand the flow, you'll be able to do it. It's not that easy. The only thing is you need to get more and more experience on that. So some of the latest happenings in VLSI I just wanted to show you. The first thing is we have moved from basic CMOS to FinFET, and now we are going to gate all around gates. So we can use this gate as a nano wire or a nano substrate. So this is where Samsung is working on for 1.5 nanometer scale. And the latest one is the IBM unveiled the 2 nanometer chip technology recently, 15 days back. So it gives you high density, high efficiency also. So in terms of performance and efficiency also. So Naresh, can I play this video?
Yes, sir, you can go ahead.
Do we have time? Yeah. Okay.
Yes, time.
Semiconductors, the foundation of data processing chips at the core of computing, are a critical component in everything from our appliances to cell phones, transportation systems, infrastructure, and even national defense systems. Transistors are a type of semiconductor. The more transistors on a chip, the more calculations it can perform using the same amount of power. The transistors are manufactured on silicon wafers, which contain hundreds of individual chips, sort of like a high-tech cookie sheet. 4 years ago, IBM created a revolutionary architecture designed to produce a chip with transistor components as small as 5 nanometers. Building on that breakthrough technology, this year, IBM has produced the world's first 2 nanometer chip. Its tiniest components are smaller than a strand of DNA. Designed and produced by IBM Research at its Semiconductor research facility in Albany, New York, this wafer contains hundreds of chips the size of a fingernail, each with 50 billion 2 nanometer transistors. This technology is designed to help improve calculation speed or boost energy efficiency, depending on the job. Where speedy complex calculations are the goal, IBM's 2 nanometer design is projected to achieve 45% higher performance than today's 7 nanometer chips. Or, if energy efficiency is the priority, they are projected to use 75% less energy than 7 nanometer chips. This breakthrough will help accelerate advancements in areas such as AI, 5G and 6G, edge computing, autonomous systems, and space exploration. The 2 nanometer chip continues IBM Research's legacy of contributions to semiconductor innovations. These include the first implementation of 5 nanometer and 7 nanometer process technologies, single-cell DRAM, the Dennard scaling laws, chemically amplified photoresists, and many others. Now that IBM Research has made it possible, it shouldn't be too long before 2 nanometer technology becomes the industry standard. This kind of innovation from IBM Research has kept IBM's technology on the cutting edge, from 2 nanometer chips to platforms like IBM Power Systems and IBM Z to quantum computing and beyond.
And one more thing is the global chip shortage is starting to have the major real world consequences because of the technology has advanced and semiconductor chips are spread all across different things. There's a very shortage of the chips now. So the first thing is the car makers are not able to fill up the gap. There's a huge demand now. And the Intel CEO has told that it will take up to 2 to 3 years to fill this gap. So there's a huge demand now in India also. So for any contact, you can just contact us at 2 email addresses of these, 7th line, Sharma or Muralikrishna. And most of the figures and data that have been taken in the slides are from Google, Intel, IBM, and YouTube. Thank you, Naresh.
Krishna.
Sir, there is a chat box. A question is given by elementally Sri Satyasai Satyadev.
Yeah.
The question is Samsung and Qualcomm, they are using the ARM fabrications or something else. He wants to know something about it.
So Samsung Qualcomm just is the architecture to ARM for processor fabrication. Yeah, ARM is an architecture. So they follow that ARM processor architecture. That's it. Qualcomm doesn't fabricate anything. Samsung fabricates it. So Samsung have their own fabrication unit. They do it. ARM actually does the processor not fabrication. They do the processor design part. That's it.
Satyadev, I hope you got the answer for your question point of view. Still, if you have any during this presentation questions, you can post in chat box or ask in a question and answer point. Okay?
Yeah, if you want to talk also, you are allowed to talk. We'll just you can raise your hands and we'll allow that. Yeah, okay, thank you.
So meanwhile, I'm trying to say that some basic details about how you will trying to participate in the counseling. What is the benefit if you write that GTM entrance exam point that I take care of that. So let me take it into that my screen. Sir, is it my screen is visible?
Yeah, visible.
So not only the VLSI and all, and we are having it as so many other courses also available, and we are offered in the various campuses in Visakhapatnam, Hyderabad, and all. And these are the following courses we are offering it. And tick mark is there, that is available, and into marking that campus, that course is not available. Along with VLSI, in the Department of EEC, we are offering at Electronic Design and Technology, and so another one more program that is also offered in both the campuses in Visakhapatnam and Hyderabad. and VLSI in Visakhapatnam and also in the Bangalore itself. We have it as the fee structure is considered as yearly course fee structure. It is a 1,10,000 course fees. And if you write the GATEM entrance examination point of view, and if you have a qualified, for GATEM entrance exam, if you qualified it, based on that your GATEM entrance exam ranks itself, we are offering that tuition fee exemption for the first year point of time. In that exam, if you got more than 180 marks score, or the national-wide GATE entrance exam, the score of the 2020 and 2021, and this academic year, I will hope the PG set will be conducted later. And if you got this much of rank, and we are giving a total 100% fee concession for the first year when you are trying to join it. And if you got a score of this below the 160 and 179 on GATE percentage, and we are offering a 75% of concession for the course fees. And similarly, the 50% and also 25%. At the time of first year, you are availing of this particular fee concession when you are writing GATEM entrance examination. Okay? And this concession will be given to the next academic year also. Those who are maintaining at 8 points above CGPA score in the final examinations of the semesters. So this is when you're writing a GATEM entrance examination, these are the concessions will be given. And apart from that, we are providing it 50,000 teaching assistants per annum will be offered for that meritorious MTech students, depending on the need and availability of the suitable candidate. So when you are joining to the GATEM, the admissions process comes under only GATEM entrance exam conducted. That is called GAT, GATEM entrance exam. And those who are willing to apply for that, and we are offering it in the next phase. We are conducting the examinations in the next month, the 4th. We are trying to conduct it, and this exam is completely online exam, and you can sit in your home and write the exam point of view. And it contains a total 100 multiple choice questions, and each correct answer is 2 marks, no negative marking. Okay. And syllabus is these are the
question.
Yeah. Yes.
For each SEM, what is the fee structure?
For each SEM, we are actually it's trying to be calculated at 55,000 a semester. Yearly fees is 1,10,000 rupees. So after completion of this exam, the syllabus, we are giving a score at the time of after completion of your exam. And based on the score, we are calling for that counseling process. And the counseling also e-counseling. You can sit in your home and log in into the portal and give your options. And at the night, we are trying to allot that whatever you are opted it, and we are giving allotment letter for that. This is a counseling process after completion of this exam. The syllabus of this entrance exam is GATEM aptitude test. That's entrance test. The syllabus is this quantitative aptitude, reasoning, and verbal ability design. And the website we are trying to call it is gat.gatem.edu. That is the website. So I'm trying to post it in the chat box also and question and answer also. So that's it.
This one question. Someone has asked in GitHub artificial intelligence it started from this year. You have started BTech artificial intelligence from 2020-21. It's actually a question by Alan Devendra Reddy. Naresh, is there anything more you need to?
either. Geetam artificial intelligence for this year. No.
Yeah.
Actually, it started 3 years back itself. It started in the computer science, and also we are introduced this artificial intelligence, machine learning in all our engineering branches. Itself.
Yeah, that's that. Yeah,
Even
that's actually
in our,
from 2020-21. Yeah. Is there any questions from the participants? Naresh?
Yeah, madam.
Yeah.
I think mostly that doesn't, and I hope they will get it out. And one more final announcement is, so those who are attended the panelist, and we were trying to collect your email IDs and all things, and we had circulate this webinar recording also. That's what. And if you have any doubts, anyway, the SAR is shared at is the mail IDs of the respective.
I'll just share that again.
Yes.
Yeah. You can also go to our website and get our mail IDs, and you can mail us.
Yes.
You can just go to VSP GITEC.geetam.edu.
You can get our details, you can mail us. Okay? Yeah.
Thank you. And,
Yeah. Thank you so much.
Thank you very much, madam. Samantha Madam Garu, Murali Krishna Garu, for accepting our invitation to give the webinar. And thank you very much, sir.
And thank you all the participants for participating. Okay.
Thank you, Naresh. Thank you.
Thank you,
madam.
Naresh. Yeah. Thank you, Murali Krishna.
Thank you, madam.
Thank you, everybody, and best of luck.
Yeah. All the best to
Please
everyone.
please
best
join
wishes.
Geetam.
Yeah.
Thank you.
We would like to see you in Geeta.
Yes.
Bye.
Bye, sir.
Okay, bye.
Bye.
Sir, Murali sir sent the session, sir.
Yeah, some student was asking.
Sir, ఏం క్వశ్చన్ సార్ ఎక్కడ నాకు కనిపించట్లేదు.
Okay, he joined late, I think.
అదే అందుకనే రికార్డింగ్ పంపిస్తాను.
Yeah, okay, fine.
భావన అకౌంట్ 80. Right, sir. End the meeting, sir.
Yeah, okay, Naresh. Thank you. Bye.